Okay, welcome everyone to today's session this afternoon on SDA Access Design Best Practice. This is a design and deployment session. Lots of info in this session around how to build SDA fabrics. Sometimes I'm going to recommend best practice and sometimes I'm going to give options around best practice. Sometimes those options are those layer 8, 9 and 10 things. They come down to maybe religion, politics and management as opposed to technical reasons why we do one thing over another, but we'll go through that. My name's AshleyBurton. I'm a solutions engineer in Australia. I've been with Cisco 25 years now. Since 2017 when we introduced SDA Access, I've been focused on fabric technology in the campus. So all things fabric. I'm actually, my focus at the moment is a fabric hyper specialist inside Cisco. So I talk about all things, whether it's LISP or EVPN. And so today's session is focused on SDA. But at the end, I'm happy to take questions on either, or you can come and see me at the end and talk about just fabric technology in general. Please jump up on the WebEx, drop the questions in the WebEx space. I'm happy to try and answer questions as we go. If we're running out of time or I think we're going down a side door that maybe isn't relevant to the rest of the people, we'll take it offline or bring it up front at the end. We should have plenty of time for questions at the end too. So, bit of an agenda today, what I'm going to cover off. I want to talk to the management plane from SDA Access perspective. I'm going to talk about the policy plane because policy and segmentation is probably one of the key drivers for what we're doing with SDA and the use case for fabric networking, okay? Then I'm going to spend a fair bit of time on section 4 here on the fabric design stuff because there's lots of options, as I said. We'll go over some basics. We'll recover some, what should be some common ground, but I just want to make sure we're all on the same page and then we'll lay out the foundations moving on. We'll talk about single site versus multi-site deployments and best practice around what you should do and when you need to consider single site versus multi-site and what we need to look at there. And then finally, we'll jump into some of the additional services and capabilities. And what I've actually done is my last slide is things to avoid, because I think it's always good to talk about, hey, you can do this, can do this, can do this, but there's just a couple of bullet points there on that last slide which really focus on things to avoid, okay? All right, with that, I thought I'd start with a bit of a fun fact about me, a couple of stories. My user ID and my email address is ashley@cisco.com. This is quite unique to have your name as your user ID at cisco.com, and I like to tell people the story how I got this user ID, but unfortunately the story is not actually as good as the outcome. But I do like to tell people, the CEO, Chuck Robbins, his email ID is not chuck@cisco.com, but I am ashley@cisco.com. So if you need to get hold of me, it should be nice and easy to remember. The other thing is, inside Cisco, obviously we build switches, we build routers, we build ASICs. The ASICs go inside the switches and routers. Sometimes we give the ASICs naming conventions. We follow a certain trend, maybe it's an area, whatever. Inside the Cat 9Ks now, we've just started to position our new Silicon One ASIC. Prior to the Silicon One, we had UADP. So Cisco engineers all understand these silicons, their names and all the rest of it. Well, I'm proud to say that if you caught on the first slide there, my surname is Burton. Inside Cisco, we built a line card, a 32-port 10 gig line card for the Nexus 7K. It was the first 10 gig line card. There was a stub ASIC in that line card, and it was called the AshleyBurton ASIC. Now, I tell everyone that ASIC is named after me because I think that's a real credible story to have. So again, the reality is not quite as good as what my story goes like, so we won't get involved with the reality. The last thing I want to tell people is that, I have a bit of my family are right into tennis and I spend a fair bit of time restringing rackets. I've got one boy who breaks a string every, hour and a half, 2 hours. And I find it really interesting because I have some synergies between what happens with a racket restring, and people probably don't really care about tennis racket restringing, but a racket and the way you restring it, the string, the tension, the string pattern, the type of string, the roundness of the string, all these things, all these variables actually have more impact on the way the racket plays than the frame itself, okay? I pull a string up tight, you can pull it up loose, it might have 16 mains, it might have 18 mains, et cetera, right? And what I like to use is the analogy that this is much like a network. the way we configure all of the capabilities we have in our network stack, all of the protocols, all of the features, right? And our Cat switches, our Cat 9K switches have hundreds and hundreds of features. The way we configure these things will directly impact the performance of that network, okay? From resilience, high availability, and all these things. So when you're building your networks, really think about how you're building them to get the best out of them, okay? Because all those protocols, certainly working together, will impact the performance of that network. All right, enough about me. Let's get into it. Management plane. Right at the top level. So let's just make sure everyone's cool with management plane. We're talking not in the data path, okay? Purely management plane. And the first one that I'm going to cover off, and this is not a Catalyst Center design session by any means, and there is actually Cat Center sessions on right now. So, but from a design perspective, we've really got three options. A standalone option, and that standalone option could be a single physical appliance, it could be a VM virtual appliance, or it could be a virtual appliance in AWS as far as the physical standalone appliances go. From a HA perspective for Cat Center, we have the choice of building a cluster of these nodes together, okay? And when we cluster from a HA perspective, what that clustering technology really gives us is that hardware level resiliency. So in the event that one node fails in my 3-node cluster, the cluster continues to operate. I can take one node out, upgrade, change some disks, do what I need to do, put it back into the cluster. I still have my availability. But be aware, for the cluster to operate, I have to have 2 active boxes in that cluster, okay, to form a quorum. And the reason I'm calling this out is because customers often say to me in the design session for SDA is, I've got 2 data centers. And with 2 data centers, and you've got 3 nodes in your cluster, well, what I'll do is I'll put 2 boxes in data center 1 and 1 box in data center 2. That's not going to give you HA, okay? That's not going to give you resiliency, because if you lose data center 1, you've lost 2 boxes, you've lost Cat Center, okay? You have to have 2 boxes to form a quorum. So your choices are split the boxes around, or you run a witness node and we start to do what we call DR. So with disaster recovery, I can put box 1 in data center 1, box 2 in data center 2, active standby, run a witness node. The witness node will track what's up and what's not up. The witness node goes in another site, okay, that 3rd site, and we therefore manage. Now there is different failover times, and I've got them here in the chart, between what's the difference between HA, that 3-node cluster, and the active standby failover, okay? For anyone interested, from a design perspective, when you're looking at, and be aware, I keep coming back to the point, this is management plane only. The system of SD access and the fabric will continue to forward packets, whether you turn Cat Center on or off, okay? You won't be able to make changes, but you won't have much visibility, but the system will continue to operate. Other important point from a management plane perspective is ICE, our Identity Services Engine. And there's lots and lots of use cases. I'm not going to talk to all these use cases for ICE. There are a couple I do want to call out. I mean, a lot of people are probably familiar with ICE and are using ICE for things like TACACS, device administration. But be aware, we want to use ICE for a bunch more things. ICE is providing me identity and context, all right? So when I'm on Cat Center and I want to know it's AshleyBurton that's connected and he's connected to this particular access point with this particular client, ICE is what's providing the context to that assurance data in Cat Center, okay? ICE is also a critical component when we're talking about SDA when it comes to segmentation, okay? ICE is my AAA service doing my authentication and authorization for me for devices as they connect to the fabric. But ICE is doing something more. It's pushing down this thing called an SGT, and we're going to talk about SGT, so it's giving me the ability to do micro-segmentation. And with that, I get a bunch of things around policy analytics, and we'll talk to some of those use cases as well. So ICE is a critical component in that management plane. Everyone in the room here today, back at the business where you've come from, is probably got some sort of framework around zero trust network access. And the adoption to Fabric, there is a bunch of choices to this adoption of Fabric. Zero trust network access is all about how we authenticate and authorize things and users and devices that come onto the network and provide segmentation so they can't see each other, they can't talk to each other, they can only talk to things they should be able to talk to. That east-west comms on the network itself. If I just want to do micro-segmentation, in other words, user Ash, user Fred, the two users, we don't want them to talk to each other, I want to do some sort of micro-segmentation. I do not need a Fabric to do that. Okay, I can do micro-segmentation, SGT policy or VLAN policy, VLANs with ACL policy, without a Fabric, okay? A Fabric is providing me my virtual networks. If I want to do multiple virtual networks on a physical network, I need a Fabric. That is macro-segmentation, okay? And so the path, depending on where you are in your journey to zero trust and doing this authentication, authorization, and policy for users and devices on your network will dictate what's the best path and mechanism and migration strategy you need to get to, okay, to get to Fabric. Be aware though, but what Fabric does provide me, if I do get to SDA, it does provide me that full macro segmentation capability. And I'll talk about exactly this when we get to the policy piece. From an ICE perspective, ICE being that identity services engine and my single source of truth for identity, often customers ask me, I've got multiple Catalyst Center clusters. I might have a Catalyst Center cluster for maybe my Australian sites and a Catalyst Center cluster for my other part of the world sites. Maybe I've split it different, East Coast, West Coast, all these sorts of things. How do I connect a single ICE and identity truth of source to multiple Cat Center clusters? Well, starting with the 2.2.3 release, we were able to actually support up to 5 Catalyst Center clusters connected to the single ICE cluster. And again, this is not an ICE deployment session around how you build ICE resiliency and ICE scaling. There's a bunch of sessions on those, but please come and see me at the end if you want to talk about ICE design and where to put your things like your PSN nodes. All right, policy plane. We've started to get into this conversation around identity. The first thing I want to talk to from a design perspective is if I'm going to do policy, do I do it on ICE or do I do it on Catalyst Center? And the choices are exactly that. They are a choice. What do I see most customers do when they go down the SD access path from a policy management perspective? Most customers will manage that policy on Catalyst Center now. Okay, that's what I see. It doesn't mean to say you can't do it on ICE still. But if you're doing it on Catalyst Center, ICE now becomes a read-only. All right, if you're doing it on ICE, Catalyst Center becomes the read-only for the policy. And under the configuration in Cat Center, you have a little toggle to select where you want to do this. Okay. But as I said, most people will see it done, that I see, will do it on Catalyst Center the minute they go down the SDA path. Interestingly enough, the one call out there's a couple of little notes there for everyone's notes later on, but the call out that I'll make is the default policy. If I'm managing on Cat Center, that default policy applies to all Fabric sites. If I do it on ICE, I can actually get a bit more granular with that, okay? However, that default policy is an interesting one. I'm going to talk exactly how that default policy works in a minute, so just bear with me on that one. Quick recap, just so we're all on the same page, because we're talking about policy, right? Macro segmentation and micro segmentation. Macro segmentation is this concept or notion of virtual networking, VRFs. It's been around forever, okay? A VRF maps to a LISP instance ID in the LISP control plane for SD access. Comms between two VRFs within a fabric must leave the fabric and come back onto the fabric, apart from a capability which I'll talk about coming up, okay? But let's assume for now VRFA needs to talk to VRFB, off box, on box, okay? So what's the box that's doing the policy between the two fabrics? This is a fusion device, okay? Now, what's the right fusion device to use? Well, the majority of customers will want to use a fusion firewall to be that fusion device, okay? Some stateful packet inspection between VRFA and VRFB. Don't put devices in VRFA and VRFB if they're always meant to be communicating with each other. They shouldn't be in two different VRFs. We should use some other technology to control that comms. VRFs are built so that we make sure that this is the exception, not the norm, okay? And we've got plenty of capability with VRFs. I've got customers, not SDA customers, that have got hundreds of VRFs. When they've started to look at SDA, SDA is given the ability to actually reduce the number of VRFs. Why? SDA gives us micro-segmentation. It's inherent in the solution. What's micro-segmentation? Micro-segmentation is the ability to do two SGTs, security group tags, which are pushed to me from the ICE, and do policy between those two SGTs at the switching layer, in the ASIC, in the hardware, at the edge of the network. This is the distributed firewall or distributed security capability of software-defined access, all right? And it's a real security capability. It's one of the things we talk to a lot of customers about when we're talking about fusing security into the network layer. So Ash joins the network. I'm going to give Ash an SGT of employee. A camera joins the network. We'll give the camera an SGT of camera. I want to stop that traffic from talking to each other. We do that with what's called an SG-ACL, and it's done at the edge of the network, okay? The edge of the network, the fabric edge. Security group policies for micro-segmentation. This is done at egress so that everyone's aware, okay? I tag the packet at ingress. I police the packet at egress, all right, where source and destination SGT are known, okay? Everyone needs to be aware of that one. Okay, all right, bit of a recap just so we're cool on all the naming conventions inside SDA fabrics, right, because we just changed the name of a few things. We've covered off the management plane, CAT Center for assurance and automation, ICE for policy and identity, okay? All right, we got those two bits. Then we've got some of the first and most important piece in an SD access fabric is the control plane node. Endpoints register with the control plane node. Control plane in SD access is LISP. When I register with the LISP map server. The map server understands the location I am. Remember LISP, location identifier separator protocol. So all it's doing is going, Ash belongs at that edge node. It's a mapping table, okay? It maps Ash to an endpoint. That is the control plane node. The border node, this is my way in and out of the fabric. Okay, within the fabric, I'm running VXLAN encapsulation. Out of the fabric, I'm not. My border node connects me to the outside world, okay? The edge node, this is where I'm doing my VXLAN encap. Hosts connect to the edge node. The edge node is the access layer of your network, okay? Host comes along, connects to the network as it traditionally would, .1x, et cetera, I get an SGT, I then encapsulate the packets that leave the edge node in VXLAN, okay? Once they're encapsulated, they may or may not traverse this grayed out icon, being the intermediate node. An intermediate node in an SD access fabric is just an IP forwarder. It is not involved in VXLAN. It's just forwarding packets, routing packets in and out. An SDA fabric pushes that layer 3 all the way to the edge of the network. And finally, I have my wireless LAN controllers, and we'll talk about wireless design and best practice for wireless design inside a fabric coming up, okay? So they're the components that make up an SDA fabric. Now going back to this policy piece, very quickly. I mentioned we have this concept of a default permit or a default deny policy that applies, if you're managing that policy from Cat Center, applies to all fabric sites in the Cat Center. Default permit and default deny, they're pretty, they're selectable, you can choose, but they're pretty self-explanatory, okay? But I want everyone to be aware that if you choose default deny, it means SGTA and SGTB will not be able to talk to each other until you write a policy or a contract that allows that to actually happen, okay? So if you are going down the path of the default deny path, you need to be aware of what are the traffic flows inside your network before you go and turn this on. Otherwise, you are likely to end up with a bunch of phone calls at the help desk saying things aren't working, okay? So understand that default deny. From a security perspective, a lot of the security folk in the room want to see the default deny, this whitelisting model where you actually write a contract around what is allowed and what isn't allowed, okay? So we do have this capability of doing a default permit or a default deny, okay? What do I see most? Most organisations, when they're moving to SDA, just back on that last one for 2 seconds, most organisations will actually start with default permit, okay? Because micro-segmentation is where they want to get to with their zero trust journey, okay? So they're starting with a traditional network. They might have VRFs. We're migrating to SDA with a fabric, and we're going to turn on micro-segmentation because the traditional network couldn't do that micro-seg easily. It was all VLAN based and IP-ACL based, okay? The great thing about SGT policy, it's based on identity, not on IP address, and therefore moves with me as I move across the network. A couple of enhancements that we've done around the policy side of things and CTS. Just, again, these are probably more for everyone's notes than anything. But now all of the point-to-point links, the layer 3 links, the routed underlay, we actually disable the CTS enforcement on those links. We disable the CTS enforcement on the links, the infrastructure links that go between our edge nodes, our extended nodes, and all of these things, unnecessary capabilities. This has now been automated, so you can actually see that all of these point-to-point L3 links are now without CTS enforcement on them. The enforcement happens elsewhere, okay? So again, just for a note for everyone. I get asked this one a little bit, not so much anymore, but customers used to ask, how do we integrate with third-party radius servers? Show of hands, anyone interested in how third-party radius servers interconnect? Yeah, so you can actually do it. There's two ways. You can do it off to the side, or you can do it where that third-party radius server is doing all the AAA direct with the edge node, and then I have to share policy from the edge node back up to ICE so I can do the SGT policy. Okay, so there's two ways to do that. What do I see most? I actually see this one here on the left done more, where they actually interconnect and use ICE as a proxy over to that third-party radius, okay? Be aware, it doesn't mean you can get rid of ICE. If you want that SGT policy, you'll need ICE, okay, in this deployment, all right? Okay, just from a .1x perspective, and again, this particular part, where we do our authentication templates, what are we actually rolling out from an authentication perspective? This is not so much SDA specific, right? So the great thing about SD access, when I run a routed access, I have the ability, and I've got customers today, where every switch port at the access layer has the same config on it. All right? And so anything can plug in, and we identify what's plugged in. We challenge it, whether it's via MAB, whether it's via .1x, or whether it's via profiling that endpoint. Right? We work out what it is, and then we assign the SGT to the device once we've authenticated it onto the network. All right? This one here is an interesting one. So if you've gone down the path of doing .1x for your wired clients already, you've got a couple of choices with this, okay, and turning on .1x. And the obvious choice when we start to authenticate all of our wired devices is to run in open mode. And open mode gives me that real, flexibility. It's authentication without it. We're going to authenticate, we're going to authorize, and then we're going to get some sort of visibility about who's what's connected to the network, but we're not going to really enforce. Okay, and then there's two approaches which you can see in the Catalyst Center template here around whether I want to go this low impact mode or whether I want to go closed auth mode. Okay, what I actually see most is more closed auth than I do the low impact mode, but that doesn't mean to say low impact mode is not right. All right, so you have a choice here around how do you actually start to enforce that micro-segmentation at the edge and the device authentication as it connects to the network. All right, this is where we really want to spend some time in this design section. So let's look at the SDA fabric design. All right, first single source of truth for everyone in the room is the Catalyst Center data sheet. Okay, this data sheet and the latest data sheet that you have available at the time of your deployment or looking at it from a design perspective goes through a bunch of information, and that information includes device hardware capability, software capability, image types, et cetera, around what is capable in the network. And I'm going to call out a few bits of it, but this data sheet is number one single source of truth. The second source of truth that I like to refer to is the validated designs, which I'll talk about at the end. And the last one is the compatibility matrix. All right? So this one here is the compatibility matrix for SDA. And anyone looking at doing a migration of an existing network to a new network, this compatibility matrix is quite important. It will tell you what hardware is supported in what role and what software release we want you to run on it. Okay, so if we're talking about that control plane node or the border node or the fabric edge nodes, this compatibility matrix will tell you what devices are supported at fabric edge, what is the recommended software for that particular fabric edge device, whether it's a 9300 or a 9400, etc., and what is the supported versions. Okay, so use this single source of truth, this compatibility matrix, as a way of knowing what to keep software releases on. I'd really like to encourage everyone going down this SDA path to try to work towards always getting to the recommended releases, okay? But that's not to say that the supported releases, aren't good, right? We just want to keep getting you to the latest tested releases inside Cisco. And these are the recommended release trains, okay? And so this compatibility matrix will list out, as you can see here on the edge, it's showing you the fabric and border node. It happens to be a 8000 router, gives you the recommended release and supported releases, okay, for that particular device. So that's the second source of truth that I want everyone to be aware of. All right, when we opened up that data sheet, I spoke about platform scale. So we're designing our network now. We have to look at the platform scale. And there's a bunch of things here on this slide that talk about platform scale, and we have to consider all of them, okay? SDA is a system. It is a solution, okay? We need to consider all these things because the capability on the face value thinks we could build a network infinitely big, right? It's routing access. But we need to consider a couple other things, okay? Let me give you some examples. Catalyst Center, for example. Catalyst Center wants to make a change to a fabric site. It's got to push out a bunch of information, right? Everything in that fabric site may or may not need that information, okay? How big and how many devices do I put in that fabric site to push out all that information to keep updated in one go? We need to consider it. There is best practice, and we always put the upper boundaries on because we don't want things growing out of control, even though the technology would suggest maybe it could be, okay? So I'll give you one example. Catalyst Center. Devices. We can support lots of devices in Catalyst Center. In a fabric site for SDA, I can put 1,200 devices. That's networking devices, not including access points. Okay, access points are additional. But what is a fabric device? A fabric device is the border node, the control plane node, the intermediate nodes, actually not the intermediate nodes, the fabric edge nodes, as well as any of the extended nodes below it. Okay, They're devices. We count them all. Wireless LAN controls are devices, we count them, but not the APs. I have a limit on the extra large appliance of 1,200 devices per fabric site. 1,200 devices, that's a lot of devices in one fabric, okay? Now, I've got some customers who have come to me and said, we want to grow more than 1,200. And my ask of everyone in this room is if you've got requirements beyond, say, that particular limit, reach out to us and we will go away and validate whether we support it. Because we are actually doing designs now, supported designs, with up to 2,000 devices in them, okay? But we have some constraints around how you do it. It's not just open book, okay? So we can do it, that's the first thing. But we look at all of these things. We look at the number of endpoints we have, how many endpoints are supported on a particular border node, and how many endpoints can we have on a control plane node. Because I've got to register the host with the control plane node, and I need a TCAM entry in border to make sure that I have a host route for every host on the network on the border node. How many IP pools do I have? How many VRFs do I have? Some platforms at the edge of our network, the fabric edges, don't support 256 VRFs. If you're deploying 256 VRFs, please come and see me afterwards anyway. But if you have a restriction and maybe you've got 30 or 40 VRFs, well, we have some platforms that only support 4. We have some fabric edge boxes that support 20 VRFs. So don't pick that platform. We've got to think of all these things collectively, just like we would with a traditional network design. There's lots of things we need to consider, okay? So all of these things come into play, and it often comes down to the lowest common denominator, all right? So think of what is the smallest number. As I said, concurrent hosts connected to the network. Am I running IPv4 and IPv6? Because V4 and V6, dual stack, additional resources on, border node, right? I have to register and have routes for those hosts on border node. So my border node scale needs to be considered. So all those things come into play. So please, lowest common denominator, single source of truth, the Catalyst Center data sheet for that particular release of Cat Center. And every platform is listed around scale numbers. But if you have any questions, please reach out to Cisco. Within that Catalyst Center data sheet, there is this particular slide, and I refer to this a lot with a lot of customers, and this is the latency slide, round trip time, for the times we need between the particular roles within an SD access fabric and the other things, whether they're the ICE node or the Catalyst Center itself. Probably the one to call out, the ICE PSN to the fabric edge, 300 millisecond round trip time, okay? People ask, do I have to put my PSN right at the how from the fabric edge can I have it? If I centralize my PSN in the data center, what's the round trip time? Okay, so please, this is in the data sheet. I refer to this all the time. It's under the latency requirements. There's actually a specific heading there now for it around what is the round trip between each individual aspect or role within an SD access fabric. All right. We offer some really flexible deployment options with SDA now. And I'm actually going to start with the one over on the right, because the one over on the right is really the foundation of SDA. And that's where we're running that routed access. So we've eliminated all the layer 2 protocols in our network, all the things like spanning tree, stackwise virtual, ether channels, they've all gone. And we're actually using the underlay, a routed access all the way to the access layer. We're routing, okay? In this scenario, I am able to do macro and micro segmentation all the way to the edge of the network, all right? I'm getting VRFs and SGTs at the edge of the network. I'm encapsulating at the fabric edge with VXLAN. The VXLAN header has my VRF and my SGT carried, and it gets carried across the network in the VTEP to the other side of the network where it gets decapsulated. So VRF and SGT are preserved all the way to the edge when I'm running routed access to the edge, okay? So macro and micro segmentation all the way to the access layer. Now, we've got some customers that say to me, that's great, Ash, but we've got some layer 2 switches like some Catalyst 3560s, the little compact switch. And the little compact switch can't do VXLAN encapsulation in hardware. Okay, what are we going to do? So in those situations, we also support the ability to have the fabric edge stop at distribution. Okay, and we push that fabric edge, the fabric edge down with just a traditional layer 2 network, things like .1Q, all the way down to the edge of the network. Okay, to the access layer. Some customers want to keep the access layer as their existing L2 network. They feel like they're comfortable with L2 at the edge. They still want to troubleshoot spanning tree. That's my subtle hint that we should try and get L3 all the way to the edge, everyone. But this is actually supported, and and I'm going to talk about those policy extended nodes and extended node types in a couple of slides. And finally, we have, and by the way, when I do this extended node capability, I'm still getting the benefits of the automation and the microseg down at the edge. So Cat Center can still do the automation and assurance, right? So I still get some benefits of just having to maintain that layer 2 network. And the last one is the one here on the left is really, maybe some third-party switches in the environment or some really, dumb kind of switches that are just L2 attached, unmanaged. Interestingly enough, these devices don't count in that 1200 device limit because they're not being managed by Cat Center. Okay, just as a little side note for everyone to be aware of. Macro and micro segmentation in the one on the left, stop at distribution. Okay, I can't obviously pump an SGT and SGT policy down to a third-party switch or an unmanaged switch that I don't know about. Okay, make sense? All right. Okay, device roles. So we've got this notion now of a fabric site. A fabric site, as I said, we have the upper limit of 1,200 switches in a fabric site. A fabric site is actually a logical construct, and it's made up of a couple of roles. Obviously, we have the border node. That border node is my exit in and out of the fabric. I have my control plane node, which we've talked about, being our LISP map server, and we've got edge nodes, the fabric edge. And we might have extended nodes, okay? And we've got a bunch of ways we can deploy these services or capabilities, these roles on the network. Option 1, dedicate every one of these boxes to a dedicated box. Okay, don't co-tenant or co-locate any of these services on any of them. I've actually got a slide coming up where I'm going to compare when you would do option 1 versus when you would do option 2. And option 2 is quite a common asked question of us around why can't you, or when would I co-locate control plane and border node on a single platform? And I'll actually step through that in a couple of slides, so hang in there on that one. The other ones, as we start to move down to option 3 and 4, we start to look at the technologies of fabric in a box, right, where we start to put all these services on a single platform, and we can do that, absolutely we can. And that fabric in a box where we're running border node, control plane node, it's the edge node as well, and it's running the WLC embedded wireless controller functionality. So there's actually what we call fabric in a box, and that is a capability we have. All of these are supported from a design perspective in different form factors, and we'll talk about when you would choose one over the other. From a fabric in a box perspective, this is that option 4 that we spoke about. How should we build this network? What does a good design look like for fabric in a box? This is that branch site. Branch site that's got VRF, so I want to do some sort of micro segmentation. The great thing about fabric in a box, I template this thing, it's cookie cutter for every site. It's the same thing, right? It's really simple. Guidance around design, less than 1,000 endpoints and only 50 APs. And the 50 AP number is really built on that embedded wireless controller functionality inside the switch, okay? So let's think about how we do that. Obviously, the fabric in a box, I could have one box doing everything, as I show on the left, one box doing everything. I can actually then subtend extended nodes or additional fabric edge nodes off that single box that's got my control plane border node and WLC capability on it. I can subtend others off it. The second option is when they say to me, oh, the branch, we need some resiliency. And so I always say, okay, well, the obvious thing to have resilient in the design is you want 2 border nodes and 2 control plane nodes, because that's resiliency, right? And they can also be edge nodes, absolutely they can, and we would build it in this fashion as per the second design here. Be aware that for a fabric site, a fabric in a box site, even though I've now got 2 border nodes, 2 control plane nodes, I am only able to do 1 WLC in the fabric in a box, okay? Just be aware of that, okay? I can't get. So because of that, I might then consider the third option along. And what the third option along is actually showing you how to run stackwise virtual around the border node control plane node. Now, I'm not a massive fan. I really want anyone who's considering stackwise virtual on border nodes to come and see me, and I'm happy for you to do it at the end or afterwards, around why you wouldn't do this, okay? Because I'm not a big fan, and we're trying to think about routed access and resiliency is splitting all this functionality out. And if we start to build border node, control plane node with stackwise virtual, we are effectively going down to 1 border node control plane node. Should the hardware fail, everything will flick over, absolutely. But it's 1, okay? Every bit of traffic goes out that 1. So be aware of this one here, right? So this is the one use case though. In the branch design, this is the one use case where stackwise virtual on the border node control plane node makes sense to me, okay? And I'm happy to do this in this scenario. And you can see how we integrate the additional bits on the end there, so you should have a good concept there. Okay, so just be aware of the fabric in the box design options for the branch. Okay, control plane options. When we first released SDA to the market back in 2017, and it's been that long, I actually built the first large-scale SDA deployment back in 2018. We went live with 40,000 switch ports in a fabric. Okay, so a good-sized fabric. The control plane we used by default, and the only option we had was this concept of LISP BGP, where we used IBGP between the control plane node and the border node. So remember, I register with the map server, the control plane node, I've got to get that information over to the border node, so the border node can program TCAM, okay, with those routes. So the way we did that is we used IBGP. Now, you probably, if you've been running SDA, you probably haven't found this to be a drama, although we found out there was a better way to do this, okay? And so now when you come to deploy SDA, the default will be pub/sub, and I would encourage everyone to go down the pub/sub path, the publisher-subscriber path, which uses LISP as the mechanism to share routes between control plane and border node and transit control plane, okay? Couple of things. First of all, I'm no longer worried about two control planes, BGP and LISP. I don't have to worry about that. I don't have to worry about troubleshooting too, and I don't have to worry about the redistribution, okay? And I will end up getting better and faster convergence with pub/sub, that publisher-subscriber model, okay? Where I'm actually using LISP as the control protocol between control plane and border node, all right? And that programmability side of things.
Quick question.
Yep.
On LISP BGP.
Yep.
Carlos, the only option you've got if in your border config is to set, your eBGP peering out. Is that iBGP peering between borders automated?
Yes, it is. Yep. From pub/sub, from a LISP BGP perspective, it is. Yep.
Thank you.
Between control plane and border. All right, border node design options. 3 choices for border node types. We have something called an internal border, something called an external border, and something called an anywhere border. Let's just quickly go over them. The internal border, this is your border that gets to your data center, your known routes inside your network, okay? Early deployments, we saw a lot of customers using the internal border to connect to their data center for the known routes as a dedicated box, okay? External borders, connecting me to the outside world, to the default route. That's where I'm getting my default from, the external border, unknown, okay? What do I see most common now? I see the anywhere border, which is simply the border that's running both internal and external functionality. Okay? And this gives me all my routes. It's just my way in and out of the fabric. It's where I'm connecting to the data center as well as where I'm connecting to Fusion first. Okay? And Fusion will get me across to the internet and outside world. All right? So that's what I see more of now. We do have a limit of 4 in a fabric, 4 outside borders in a fabric. So be aware of those, that limit of 4 anywhere or 4 outside. Okay? All right, let's go back to this co-location because I get asked this a lot. Obviously, separating control plane and border node gives me some scale, some flexibility, and maybe the concept in my head of a slightly more available best practice design. And it certainly did in the early days. So in the early days with that 40,000 fabric that we built in 2018, I separated them out. And I separated them out because the control plane for the number of endpoints that needed to register was starting to get to the limits of what a control plane border node co-located box could do at the time. Right? The number of concurrent endpoints on a control plane was going to exceed or get very close to the limit of what the border node could do if it was also doing control plane node. Okay? So we separated it out. We also did a design, about 20,000, for a hospital back in 2019. And I then used a different set of logic that I wanted that control plane separate on a physical box because I wanted to be able to do an upgrade to a border node without impacting my control plane node. Because the control plane node is the center. Every device has to register with this control plane node, right? And there's 2 of them for resiliency. So it gave me a little bit more flexibility. So you get the choice of flexibility versus the alternate option, which is co-locating. If we don't have that flexibility in design and scale constraints, let's co-locate. It's certainly more cost effective, it's less hardware. And in fact, since Cisco's been releasing the Catalyst 9500H platforms to market, we've seen the numbers from a scale perspective get to the point where it's not even a scale conversation to co-locate anymore. In the early days, we did have scale constraints. Now, if I look at it, that 9500H platform, that high performance platform, co-locating it is actually now quite acceptable. But it doesn't solve that notion of that high availability that I might want to consider. Okay? That thing around, I want to take just the control plane out. Or if I need to upgrade just a box because it's got a control plane issue, I don't want to have to bring down the border as well. That it does take that away still, okay? But I could certainly do it. It's probably a simpler design to co-locate, right? I don't have to have an underlay network getting between control plane and border node. It's on the same box, right? And it's obviously cheaper from a CapEx perspective, and we understand that. And it is capable to do it, okay? 2 design options. I think they're pretty self-explanatory. Choose the one that's right for your organisation. Sometimes the answer is not a technical one. The answer will come down to that layer 8, 9 and 10 issue, right? It's a religion, management or politics, one of those 3, that'll decide which way we go. And that's what happens, and that's okay. All right. Edge node design. This one should be pretty simple and self-explanatory. Edge nodes, the access layer switch. With a routed underlay, I'm connecting 2 links up. My underlay's routed, ECMP multipath, looking after the resiliency and load sharing all at the same time. From an edge node perspective, I can do a standalone switch, I can do a stack of switches, I can do a chassis-based switch. Okay? All are supported options. If I do a stack of switches, that only counts as 1 edge node. Okay? If I do a chassis, it only counts as 1 edge node. And this is a classic example where one of those, back to the scale requirements, we actually look at number of physical ports in the network from a Catalyst Center perspective within a fabric site. because one standalone switch isn't the same from a CAT center assurance data perspective as a stack of 8 switches or a chassis with 4 or 5 line cards in it. Okay? So there's another thing that we're always considering back on that scale one, number of ports as well, all right, from an assurance perspective. And with regards to multi-homing, this is this little capability down the bottom here. You'll see a switch. I've connected it to 2 edge nodes. How do I do multi-homing? Those people familiar, as I said, I'm doing a bunch of work with Fabric and BGP EVPN. BGP EVPN fabrics, we have this notion of ESI multi-homing capability, active links to 2 uplinks to 2 leaf switches, a leaf switch being an edge node. Well, in SDA, we don't. We don't have this capability of active downstream multi-homing, okay? So there's a couple of things that you need to consider. We can have a switch and we can use FlexLink Plus technology so that all traffic will forward out one edge node. Should one of those links in that path fail, it then alternates to an alternate path. It is not a ring technology. If you want a ring technology, or you want to run, whether it's spanning tree or rep or whatever, it needs to come back to the same edge node. It needs to come back to the same edge node. So multi-homing is our one thing we don't do from an edge node perspective other than FlexLink Plus. That is supported, okay? The reason I bring that up is that it's often brought up, and it leads me to my next slide, when we talk about these extended nodes, because of when we're doing IoT integration and integration in more of those manufacturing and mining kind of environments where we have lots of extended nodes or these IE platforms, okay? It also comes up in universities a lot because they use a lot of the compact switches in lecterns and AV spaces, okay? So there are 3 types of edge nodes. We have this concept of a extended node and a policy extended node and the supplicant-based one. The ones I'm going to focus on, extended node and policy extended node. The big difference between extended and policy extended is just that SGT capability down at the edge, okay, for micro-segmentation. Most customers I talk to that do this start to do the policy extended node capability, all right? Because I want to get that micro-segmentation as close to the edge as I can. I'm trying to stop east-west traffic with microseg. That's the goal, okay? Now, having said extended nodes, good use case is the IE platforms, the IE 3400s, for example, or the compact 3560 switches. Those boxes were not capable of doing VXLAN NCAP. Okay, the ASIC in them couldn't do it. Well, the new compact switches, the compact 9200 switches that Cisco brought out about 12, 18 months ago now, they can actually do VXLAN NCAP. And if the license level for a policy extended node and a standard fabric edge is the same, I would argue, why wouldn't you roll that out now as a fabric edge node and push it all the way to the edge and run routed access as far as you can? The minute you run routed access as far as you can, you are now topology agnostic. I don't care if it's a ring, I don't care if it's a straight line down a railway line, and I can connect to this edge node, ring, this edge node, because it's all layer 3 now. It's routing. So I get flexibility. I can't do that with layer 2. So the new IE 3500s support VXLAN NCAP. Why? Because the ASIC is the UADP ASIC that's in the CAT 9300 family today. Okay, it's the same chip. All right? So make sure you think about my use case for extended nodes and policy extended nodes. This is what's capable. It's what we need to consider if we're using an existing fleet of IE and compact switches. But be aware the new IE and the new compact switches support that VXLAN, and we can run VNs all the way to the edge. How are we going for time? Half an hour. All right, V4 and V6 support. We have always supported V4 and V6 in the overlay for SD access, okay? The underlay is V4 only, so the point-to-point links. Now, having said that, we have just announced and released V6 for the underlay. So anyone who really wants to deploy in their underlay network environment that they're rolling out, if you want that layer 3 routed access to be V6, it can be, okay? It's coming. If it's not out, I just want to be careful on what I've seen. It's either out now or it's about to be out in December, okay? But it's very close, all right? So V6 in the underlay is now supported. Everything else is pretty much stock standard. The one thing you do need to keep in mind, as I said, I've already highlighted this one. If I am dual stacking, I need to consider the scale of that border node control plane node. Border node needs to program everything in TCAM. And TCAM resources on, and so my border node needs to know everything about everyone. It knows all hosts, okay? Edge nodes don't need to know it, but my border node needs to know Ash is on that edge node, et cetera, right? So border node must have a route for all hosts, which gets programmed in. Now, if I'm running dual stack, I not only have an entry for V4, but I have entries for V6. And most V6 deployments, when I go down the dual stack, I need to look at how many addresses are programmed. Well, typically when I dual stack, a host will have somewhere between 4 to 6, 7 addresses. And we need to program them in TCAM, okay? And every one of those that goes into TCAM takes a slot. And in some of our platforms, a V6 address will take 2 slots in TCAM, not 1. So please, if you're doing V6 deployments, again, come and see us and make sure we understand the scale of that border node. That is a critical piece to the puzzle. All right. What about critical and shared services? Where should I place them? I get asked this a lot. Typically, we will put critical services, DNS, DHCP, maybe WLC, other things in a services block. That services block could be in a local DC, or it could actually be in a remote DC. This peels back to that chart around latency, round trip time requirements that we have between whether it's local or remote. How far does my PSN need to be away from my edge nodes for that authentication to still be successful? Okay. So this one here, both are shared. No right or wrong answer, both are possible. I see the majority of the local DC where it's possible, right, for SDA fabrics. All right, SVL, I've already spoken about SVL. I'm not a fan of running stack-wise virtual in the fabric topology, and I'd really like to, other than that fabric in a box, understand the use case that you might have for stack-wise virtual in your fabric topology. Okay? Because the minute I run stack-wise virtual on my border node, control plane node, I'm now running one border node control plane node. Right? Stack-wise virtual is a single control plane. Single control plane. Whereas if I run 2, I've got 2 control planes. Okay? So if I separate that out. So these are the requirements, the capabilities. For stack-wise virtual, this is for your reference only. As I said, please reach out to Cisco if we need to look at stack-wise virtual in your fabric design. Okay, I really encourage you. Fabric in a box, it makes sense to me with fabric in a box. I'm not sure about all the others, so please reach out. All right, wireless. We need to get cracking here. So wireless, there's 2 deployment modes for wireless, and what I see people move from over the top to fabric enabled. Okay, so over the top Wi-Fi, the way it works, we build a CAPWAP tunnel, just like traditional Wi-Fi in a traditional network. The AP has a CAPWAP tunnel for control plane and data plane back to the controller, the WLC. Okay, that CAPWAP tunnel means that everything goes in that tunnel that's wireless traffic. Traffic hits the AP, goes in that tunnel all the way to the central controller. Okay, it's over the top. Policy for over the top done at the WLC. It's 2 ships in the night, right? So I've got my wired network and my wireless network. I have to run over the top Wi-Fi until my wired network is running SDA. So I have to do that. Because to run fabric-enabled wireless, what fabric-enabled wireless is simply the ability to split control plane and data plane. So now my control plane from AP to WLC is still in the CapWAP tunnel, but my data plane is VXLAN, and the VXLAN in cap happens at the AP. We decap it at the fabric edge box where the AP attaches. And when we decap it there, we now treat every wireless packet the same way we treat a wired packet. Now that's pretty cool, because now I'm doing policy for wired and wireless in the same spot. Okay, that's the advantage of fabric-enabled Wi-Fi. The other advantage for fabric-enabled Wi-Fi is I just distributed my Wi-Fi performance out to every AP. I'm no longer constrained by that centralized WLC and its throughput performance, or the switch that it's connected to and the number of MACs it supports. I just distributed it out. Okay? I'm a big fan of fabric-enabled Wi-Fi. All right, design options for WLCs. Probably the most common and the one I really want to talk to people about is making sure we go down the path of that shared services block, whether it's SSO or N+1. We have that shared services block. It allows me to ether channel, because the shared services block is where I want to run that Stackwise virtual. The reason I want Stackwise virtual in a shared services block is I don't want Stackwise virtual on my border nodes. I want Stackwise virtual because my WLC will want ether channeling. Okay, I want to be able to create that lag. Okay, so this is the most common design. APs always reside in the infrastructure VN, the global route table. APs are in what we call a local mode. Purely for your reference only, there's a bunch of WLCs up here which I hope customers are no longer using, but this is simply a scale chart for your reference around the number of APs that are supported by which controller and the number of clients. Okay. All right, fabric-enabled Wi-Fi, HA N+1. So N+1, right? N+1, we basically have to rebuild the CapWAP tunnels. So in the event of a WLC fail, I rebuild all the tunnels. There's probably a little outage. Again, this is not a wireless design session. There'll be that little outage while we move all the tunnels across to the secondary WLC. All right? The difference between that one and this guy is that failover is now seamless. And it's the WLC that'll let the control plane know in a bulk update that, hey, we've now got all the clients. Okay? And remember, in fabric-enabled mode, the WLC is only control plane. It's only control plane. It's not data plane. All right, device onboarding. I'm building my underlay. I want to do LAN automation. We've done a bunch of enhancements to LAN automation over the years. You can see some of them here, from simple things like LAN automation, where all the point-to-point links in my underlay were /26s. We've now given the flexibility a bit more stringent on that use of that range. But LAN automation can be done a couple of ways. Today, LAN automation is still ISIS. This is the underlay protocol that I'm talking about for the routed access, okay? It's still ISIS. Every box is configured as an L2 router in the IS world, okay? A level 2 router. We are currently in beta for OSPF in LAN automation, okay? So we're doing some beta right now. And I expect come March that this to be released to the wild, okay, for OSPF. And I get asked a lot because customers say to me, I don't know ISIS, I don't want to use ISIS, can I use OSPF? You've always been able to use OSPF in your underlay. Unfortunately, you haven't been able to do LAN automation with OSPF, that's all. We can still do a semi-automated OSPF design, which I see lots of customers do. I've got a couple of large universities and some hospitals running OSPF as their underlay. And the way they've done it is they build a template and they use plug and play with the template to automate it out from Cat Center. And there's your underlay built. The config that went into that template, though, that gets pushed out, is your config versus LAN automation, which will be Cisco's. Okay? No big deal. All right, let's keep moving. We support both overlays, both L2 and L3 overlays. L3 overlay kind of should be self-explanatory. The Anycast gateway sits on the edge box. I'm a host, I've got a 10.10 address. My default gateway is 10.1. Okay? If I move from that edge node to this edge node, my default gateway is now on my local edge node that I've moved to. 10.1 is now here. It's an Anycast address, so it's on every box. I can do layer 2 overlays where the gateway is outside the fabric. People do this for some of their older systems. Maybe they've got a bunch of security cameras. Is a use case I've seen quite a bit. And the security cameras have got physical addresses on them. They don't use DHCP. They don't want to touch all the physical security boxes, and they're doing a migration from old to new. We have to just keep in mind when we're doing L2 outside of the fabric, when I do an L2 handoff, I need to consider how do I do that resiliency, okay? Because I don't want to end up with a STP loop, back to the old spanning tree days, right? So we need to make sure we've considered that. All right, and the last one is fabric zones. So fabric zones are kind of cool. It's a new thing we brought out. Zones give us a little bit more flexibility. What zones are is basically the ability to control which edge nodes see which VRFs or IP pools. So if I've got 10 VRFs, 10 IP pools, I can say, right, these IP pools are on these edge nodes, and that's all they're ever going to see. And these IP pools are on these edge nodes. And I don't need to know everything about everyone, okay? So it's kind of cool from a security perspective. It's also cool from a scale perspective. If I think about fabric scale, I've got a platform in the 9200 family that only does 4 VRFs. With fabric zones, it can be part of the fabric, and I'm not working to my whole fabric is only 4 VRFs anymore. Because I could do 30 VRFs everywhere else and only have that 9200 only see 4 of them if I need to with fabric zones. Okay, so this is a cool capability. It's absolutely a design option. There's workflows for it and everything around how we do it. This is how, when I mentioned that 1200 device limit in a fabric, scaling it to 2000 and beyond, this is the capability and the restrictions that we're going to put in place to get that scale capability. You won't be able to have every IP pool on every edge node as we grow beyond 1200. Okay, multi-site design. Single site versus multi-site. Ash's best practice, do single site if you can. Do single site up until the point where something is broken or it doesn't make sense to do single site. Okay, single site means one control plane border node for a bunch of buildings or a bunch of sites, and we'll have an IP links connecting everything together. And my IP links that connect it all together are just purely that. They're intermediate nodes. All right, go back to the latency, a round trip time chart. One big failure domain though, and I do have scale limitations, right? Around back to that single border node, how many endpoints per site? Am I dual stacking? All those things, right? We have to consider it. So this is really simple. I've centralized border node control plane node. As I said, we've got some customers running fabric sites now, 60,000 endpoints, beyond 80,000 endpoints, okay? In a single fabric site. But there's what you can do, and there is, let's not be silly because it's one big failure domain, okay? So again, this is not a right or wrong thing. This is a design session around what do I see? But this is absolutely capable. Nice thing about this is end-to-end segmentation, end-to-end multicast, end-to-end VRFs, all of those things. It's all here, right? It's very simple. Let's say I want to break it up. Okay, and I might have to break it up for scale or whatever the reason is I'm breaking it up. I've now got, in this diagram up here, I've got 3 sites, 3 border nodes, control plane nodes. Remember that entity of what is a fabric site? I've got 3 of them. I can do an IP transit. This is just VRFs between the sites. I'm now responsible for carrying the VRF from site 1 to site 2 because at my border node, I'm handing off VRFs. Okay, so I've now got to run a VRF technology between each of these sites to join them all together if I want the VRFs to be consistent. And that VRF technology, whether it's VRF Lite, whether it's VXLAN, they are your options for bringing these things together, okay? IP transit. Allows me to, if I do an IP transit like this and I'm carrying all those VRFs everywhere, I could centralize my Fusion device. It means I don't have to do Fusion at every particular fabric site, but I'm now responsible for carrying the VRFs. Be aware that VRFs, how do I get the SGT, the microseg to fusion, if I want to do policy on SGT as well? If I'm doing an IP transit, I now have to do some sort of inline tagging, because when I go over a layer 3 boundary, I lose my SGT. SGT's in the L2 header unless I'm encapsulating it in VXLAN. So when I do an IP transit, I've lost SGT information. I have to do inline tagging across the network. Multi-site is another option, SDA multi-site. And this is where we build an SDA fabric to join the other fabrics together. So we've got fabric site 1, fabric site 2, fabric site 3, and we build a 4th fabric site, which is our transit fabric. The big advantage of this, micro-segmentation end-to-end with scale, with the failure domain separated out. Okay, so this is a recommended solution and the way we would look at this. It does require something called a transit control plane node. It is not in the data path, and the transit control plane node is responsible for knowing the prefixes of each border and what's available, because it's got to know everything. Okay. I don't know if there's anything else there that I need to talk about. It's transit is absolutely possible with LISP BGP and LISP pub sub. Okay. All right, transit design means I've got this transit control plane connected to my fabric site with the border node, control plane node, and then I can centralize fusion at the data center. I'm carrying VRFs everywhere. I'm carrying SGTs everywhere. Okay. Just be aware, we do need to look at MTU and round trip time. Okay, jumbo frames. All right, if you've got a WAN in place with SD-WAN, we can also do macro and micro segmentation. We can carry VRFs and SGTs if you're running Cisco's SD-WAN solution. And it's probably the one differentiator that one of the differentiators we bring with our Cisco SD-WAN working together with the Cisco SDA, macro and micro segmentation over the SD-WAN, okay? How do we do it? Border nodes everywhere, obviously at the branch, bring it back, we encapsulate it over the SD-WAN protocol. Clusters, we can either do, you've got 2 cat center clusters, cat center cluster 1, cat center cluster 2. We can actually bring these together with an IP transit, or we can build them with a shared SDA transit. If you're getting to the size where you've got multiple clusters and you want to bring these clusters together, please come and talk to us about the best design practice to do this, okay? We also have capability around what we're doing with that manager of managers for cat center as well, which is another capability. And we can do this with SD-WAN. My apologies. There's one more there. All right, last section. Services. Thanks for hanging in there, everyone. We're really moving along now. Okay, some of the services that I want to talk about. The first one, route leaking. Traditional route leaking versus LISP extranet. The ability to get traffic between VRFs without having to go to fusion. Okay? Think about route leaking. We have a capability called LISP extranet. LISP extranet will pretty much do exactly as it says, and it's designed to create this shared services VRF, maybe where you've got your printers and other things, something that all VRFs might want to see. And rather than sending that traffic from that VRF through the Fusion firewall, using LISP, we can actually get the traffic to be shared to the other VRFs, route leaking. Okay? But LISP extranet is not designed to be, for those of us in the room that are MPLS or BGP EVPN gurus, traditional route leaking of many to many, where it's an exchange of route targets and route distribution capability, importing and exporting of targets. It's not that. It's designed to be that shared services. It's designed to be able to have where, like I said before, printers shared back to your other VRFs because you want to share it. Okay? Make sense? We don't want to send the traffic through the firewall. We feel like it needs to have its own VRF so we can leak that traffic in that direction. All right? Multicast. Bunch of questions around multicast. And this in itself, and I'm not sure if they're doing it at this Cisco Live, we do a 2-hour session just on multicast design for SDA. And so this is really just meant to be a little bit of an eye-opener. We support ASM, SSM. We support RPs in the fabric, outside the fabric, on the border node. I've tried to encapsulate in the table below what I see most common from a design best practice perspective around that RP placement. Okay, where do you put your rendezvous point? What's supported? What isn't supported? You'll see now that the per VN RP, as an example, the multicast workflows in CATSAN have been significantly improved around what is possible and what isn't possible. But we do have two different mechanisms for forwarding of multicast traffic inside a fabric. Okay, those two different mechanisms are what we call head-end replication and actual native multicast. Head-end replication was the first one. We came to market right at the start. And basically multicast traffic was then encapsulated into the overlay and carried by the overlay. The disadvantage of head-end replication is that it's probably not the most efficient use of the underlay or the resources under the network. What do I mean by that? If I've got two edge nodes connected to a distribution block and I'm doing head-end replication, that distribution block will actually see two streams because it's got to get to two edge nodes because there's two receivers. Does that make sense? Okay, I've had to send a stream to each one. Native multicast actually uses the underlay multicast. And so what that means is my distribution block will actually only see one stream. And it's at the distribution block that I would separate that out to the multiple streams to the two edge nodes. So I'm using the multicast capability of the underlay to help. All right, so it's better, it's more efficient capability. However, we don't do V6, but we do utilize better resourcing and better scale capabilities, and it probably makes more sense to a lot of people to use the underlay multicast from a multicast replication perspective. But head-end is very simple. It's almost like tunneling the traffic. We just got to think everything comes back to Rome, okay? And if I've got multiple receivers, am I using across multiple edge nodes, is it the most efficient use of the resources from a multicast perspective? We're treating it almost like unicast, okay? So be aware of the two ways that the two work. Okay, last couple of bits, team. Wireless guest design. I get asked a lot, what's the best practice for wireless guest design? And we do support the multi-spot remote border capability, where we can anchor the wireless traffic back to a wireless controller in maybe a DMZ fabric site. So you get to anchor that traffic back. I don't see lots of customers do this. What's right and what's wrong? Is this the best way, or is the next one I'm going to show you better? I see a simplicity about the next one that I don't see necessarily with this one, and a lot of customers will adopt the other one. So let me show you the other one. You just a couple of caveats there. 9800 can support up to 8 control plane pairs. I'm hoping I don't have to talk about AirOS anymore. VXLAN cannot be fragmented, so we need to make sure that MTU is supported across those fabric sites, getting it back to because it's a different fabric site where the guest anchor sits, all right, that multi-site router. This is probably the simpler design, and I see more of this than I do of anything else when it comes to wireless guest. And that is when I'm running fabric-enabled Wi-Fi, remember, I break out that traffic at the edge network where everything's broken out. Well, let's stick that SSID and that traffic straight into the wired guest network, which is a VRF. And I carry that VRF all the way to the DMZ. And it's outside of my network straight away. It's just another VRF on the network. Does that make sense? I see a lot more of this because it's just simpler than I do of anything else, all right? I think it's L3 handoff from the border to my Fusion device or direct to a DMZ site. Just pure VRFing, okay? Really simple. The benefit of this is this applies to not only wireless traffic, but it also applies to wired traffic. So now, if I've got this concept of every switch port's got the same config, and I've physically hardwired some of the UTP ports around my location and someone walks up and plugs into that UTP port, or they unplug a device and then plug their laptop in as a guest, right? I am also offering guest wired access as well as wireless access by doing this, because I'm getting that traffic to the DMZ as well. All right, so that's why I like this. I really like this. All right, last one. Things that aren't supported. And this is really for your reference. What I wanted to do is call out a couple of them. And there's one here in particular, ISSU on fabric nodes. We are currently working on ISSU for the 9400, where the two SUPs in the chassis. ISSU support inside SDA access on Fabric Edge, and it should be ready to rock and roll in GA by September next year. We're doing testing at the moment. Okay, it's in beta. All right, but it's committed and it's happening. So even though it says that, just be aware that it's a coming one. MPLS termination on borders. Stay away. It's a bit like the TrustSec thing, or inline tagging. We don't do inline tagging on MPLS world. Okay. So let's use our borders. Let's think of our borders as VRF handoff, layer 3 handoffs outside of the fabric. Keep it simple. MACsec between switch to host, not supported. Keep away from it. And that dual homing. Remember, I called out that dual homing. So if dual homing is a requirement, we need to look at how we do that dual homing. All right? And finally, again, just for your reference, this one here is all around the collaterals that have been built and available, because SDA, as I said right at the start, it's been available since 2017. We've been deploying production large-scale networks since 2018. We're now up to over 5,500 customers globally, 38,000, 40,000 and growing fabric sites. We have this data because the data is coming back to us from CAT Center. So this is an enormous penetration of fabric technology. And so with that, we've been able to build a lot of collateral around best practice and validated designs. Now, there is a Cisco SDA CVD, but there are also vertical specific validated designs. So if you fall into one of these verticals, whether it be healthcare, finance, etc., you can actually download the dedicated vertical specific CVP for that, which is the profile. We also have a YouTube channel for all the SDA stuff, which you can go away and watch all the videos. Plus there is the documentation, obviously, and don't forget that Catalyst Center data sheet, okay, and your compatibility matrix. All right, and with that, I'd like to thank everyone for your attention and your time. I really appreciate it. I am going to be around for the rest of the conference. More than happy to meet with people. Come and talk to me afterwards. See me outside. See me wherever. I'm more than happy to talk to you about your SDA or Fabric in general deployments and help out where I can. Please fill out your evaluations and thanks for your attendance. Thank you.